So basically, we are simple microscope. It's a converging or a convex lens of small focal length and placed in air. In order to use a simple microscope object, this lens is held near the object, and the eye is always placed on the opposite side of the object, right? So object is placed between optical center and focal focus, so that an erect virtual and enlarged image is formed. So if I use a convex lens of very small focal length, then the lens will be like this. Okay, and if I place, suppose this is the focus of the object. If this is the focus of the object, and if I placed this object over here, if I place this object over here, then what will happen? The light ray will go like this, and it will pass through the other focus. Please use scale pencil for this. And the one which is passing through optical center, okay. So guys, when you produce this light ray in the backward directions, these are your incident rays, and since it is passing through, so these will be your refracted rays. When these refracted rays are produced in the backward direction, ऐसे तो और दूर जाके मिलेगा ये, but still for sake of simplicity I'm drawing it over here. Let's say here. So where is the image getting formed? The image gets to form over here. If I name this object as A B, this object is A dash B dash. So ये सबको concept clear है, I guess, right? Is this concept clear, guys?
Yeah.
ठीक है. Now suppose.
Sir, can you also explain that line that I sent you on WhatsApp, the confusing line with relation to the simple microscope?
What one line?
There was that really confusing line, right, that I sent?
मेरे को याद नहीं है यार.
Okay, I'll send it to you now, and you can explain it after you're done.
Okay. So इतना clear है, guys? Have you made the diagram? Now suppose here you have two different cases. You can have two different cases over here. First case is when the image is produced at, and please remember, where will you place the eye? We'll place the eye over here. Object was on that side, eye is in this side, then only you'll be able to see the image of this object at this point, right? Yes or no? So the first case is when the image is produced at the near point. Okay, so if you want to the image to produce at the near point, then what will you do? Case 1 है ना. तो देखो, in the same diagram, if the image is formed at what? The least distance of distinct vision. So suppose this was the object A B, and its image forms over here, A dash B dash. So if this image is at the least distance of distinct vision, so basically this image distance will become what? D, right? Yes or no? Hello?
Yes, sir.
है ना? So if you remember, this was the ray. If you remember, one ray was like this, right? So let this ray be like this. So can you see when the image is over here, this is basically the least distance of distinct vision. Now I have defined two angles. I defined two different angles. What are those two different angles? First angle is basically alpha. Alpha is basically what? Guys, can you tell me what is alpha? When object
Angle selected by the object.
is
Yeah.
placed at least distance of distinct vision. So basically, if this object AB, in spite of placing it over here, if I place this object over here, so this angle, can you see if I connect these 2 points? So can you see this angle, guys? This is your alpha. Okay. So basically, when object is placed at least distance of distinct vision, then the angular size of object is alpha. Then the angle subtended by this object at the optical center is basically alpha. ये समझ में आया इतना? Is it clear? Alpha is basically what? When object is placed at least a distance of distinct vision, then the angular size of the object is basically alpha. But what is beta? Guys, what is beta? When image is at least distance of distinct vision, then the angular size of image is called as beta. Is it clear? So basically, can you see the image was a dash b dash, and this image was placed at d distance only in case one. So basically, this angle, can you see this angle? Guys, can everyone see this angle? A dash o b dash is basically what? Beta. So angle A dash O B dash is equals to beta, and angle this one A B O, not the, इसको क्या नाम दूं मैं? What shall I name it? Shall I name it as CD? So C O D O is basically alpha. Is it clear, guys? Please remember CD is the same as object only, but just to avoid the confusion, I'm naming it as a different point. So when this object is placed at the least distance of distinct vision, that was alpha. And when the image is formed at least distance of distinct vision, that is basically beta. Is it clear? Is it clear, guys? So can you see two different triangles getting formed? There is this triangle COD, and there is this triangle A dash O B dash, right? Yes or no? Guys, hello? Can you see two triangles getting formed? This was the triangle which had the image. This distance is basically D. This distance is basically beta. And there is this, and this. C, D, and O. This angle was basically alpha. This distance was again equal to what? Least distance of distinct vision. Yes? Clear, guys? Is this clear, guys?
Yep.
So from here, can I say tan alpha is equals to, if I say CD is basically the height of object, so CD is basically the height of object only, no? CD and AB were equal. Yes? So tan alpha is basically HO divided by OD. OD is basically the least distance of distinct vision. Similarly, here tan beta will be equals to what? Tan beta will be basically, what is A dash B dash? A dash B dash is basically the HI, right? So HI divided by T. Is it clear?
Yeah.
Is it clear? अब this is equation number 1, this is equation number 2. Since for paraxial incidence, we know this particular thing that we are always talking about paraxial incidence. If paraxial incidence is there, then can I say alpha and beta will be small? If alpha and beta will be small, can I say, acha, by the way, uh, is this distance hi by d which I have written, is it equal to h upon तो बाद में आएगा.
So don't we use sign convention here?
नहीं नहीं, अभी साइन कन्वेंशन नहीं, वी आर जस्ट सीइंग द ट्रायंगल्स, स्मॉल स्मॉल ट्रायंगल्स. ओके. अच्छा guys, there is one, abhi don't use sign conventions over here because the formula which we have, no, they don't have any sign conventions, है ना. यहाँ पे you don't use sign conventions because directly we are putting the values, nothing else. There is one more triangle which is found. Do you remember this triangle? Can you see ABO? Can you see ABO? So will ABO form over here? ABO, yes or no? एक बार फिर से दिखाऊं क्या? Can you see triangle AOB, this triangle, and A dash OB dash, they both are similar, right? This distance was basically the object distance. So I can write tan beta is equals to hi upon d, and also I can write it as ho upon u. I'm not putting any sign conventions as of now. I'm just using trigonometry, nothing else. Is it clear? Guys, is it clear?
Yeah.
So can you see from here, if what is magnification? Magnification by definition is basically height of image upon height of object. Yes? Yes or no? So if angles are small, I can write the equations 1 and 2. पहले मैं लिख लेता हूँ. Equations 1 and 2 becomes alpha is equals to ho upon d, and beta is equals to hi upon d and ho upon u. इतना मेरे को पता है ना. Tan alpha can be written as alpha and beta can be written as tan beta can be written as beta. So if magnification is hi by ho, so can you see from here alpha by d, alpha into d, ho is basically alpha into d, and beta is basically hi is basically beta into d. Yes or no? D से D cancel. So can you see from here magnification which I was talking in terms of hi by ho can also be represented in terms of beta and alpha like this. Is it clear? इतना clear है? Guys, is it clear this much?
Yeah.
Okay. Now, please remember, if magnification I can write in terms of beta and alpha. Also, can I say m which is equals to beta upon alpha? Can I write alpha as again ho upon d, and beta as ho upon mu, ho upon u, not mu. The object distance and the least distance of distinguishing. ये से ये कटेगा and it will be equals to d upon u. So magnification has one more formula. So if someone tells you to write in terms of the least distance of distinct vision and object distance, then also you can write it like this. Don't use sign convention because this is case specific. No, it is case specific. Yes or no? This simple microscope is only when the convex lens sixth case is there, right? So this is basically your magnification formula beta by alpha. Is it clear, guys? Any doubt?
No.
Okay. Now tell me what will happen. Second case two. Why am I explaining this much in detail? Because you'll get to know the answer very soon. So case two is when the image is produced at infinity. When the image is produced at infinity, that implies you want a very highly enlarged image. If you want a very highly enlarged image, then what will happen? The object shall be placed at, this object shall be placed at, guys, if you want a highly enlarged image, then where shall the object be placed at? Array normal convex lens case. If you want the highly enlarged image, virtual enlarged image form, then where shall the object be placed such that you get this highly enlarged
Focus.
focus? तो basically object को कहाँ पे रख दिया मैंने? AB is kept at focus. So image object distance is basically equal to F. And here the image gets formed at where? Where is the image formed?
Infinity.
So image forms at infinity, right? So object distance is basically what? This much. So here if I do beta and alpha, can you see over here beta and alpha will be, image is formed at infinity, but still beta and alpha will be like, this thing. So do you remember M was equals to what? M is equals to D upon U, right? So I can write it as H upon U. If you remember, ये याद है तुमको, HO upon U. So HO upon F, because object distance is equals to F, or you can directly write, is it clear?
Hmm.
Achha, this formula can also be termed in terms of focal length as well. The previous formula, case 2, case 1 formula can also be written in terms of focal length. If I want in terms of focal length, if you remember, for the lens, the object was at U, was basically U. V was basically the near point. The image was formed at the near point, right? Yes or no? And focal length was basically F. याद है? So 1 by V is equals to 1 by F plus 1 by U. So from here, can I write? अरे नहीं, I need to use this with some conversion. 2 minutes, guys. That's it. So U equals to minus U, V equals to plus D, F equals to plus F, and then from here I can write 1 by U is basically 1 by F minus 1 by U, which I can write 1 by plus F minus 1 by minus U. So from here, ठीक है guys. So you have seen the diagram. When the object was placed at a distance U, the image was formed at the least distance of distinct vision, right? V was plus D. You remember V was plus D. Can you see V is forming at plus D? Object is sorry, V is formed at minus D. वही तो गलती हो रही है. यहीं तो वही तो बोलो. There is something wrong which I am not able to see. हाँ. So object distance is minus U, V is equals to minus D, and focal length is plus F. And we know by this formula, 1 by F is equals to 1 by V minus 1 by U by length formula. So from here, can I write 1 by U is basically 1 by V minus 1 by F? Can I say this? Guys, can I say this? So from here, U की value कितनी हो जाएगी? 1, this will be equals to what? This will be equals to 1 by minus D. Can you see image was formed at minus D? Minus 1 by plus F is equals to minus. Hello guys, थोड़ा बहुत समझ में आ रहा है what exactly am I doing?
Yeah.
So from here, can you see minus 1 by u is equals to minus 1 by d and then minus 1 by f. So from here can I write u is basically df upon d plus f on solving. Can you see minus and minus sign will get cancelled? Here you won't use sign because you have already kept with sign. Up this u I can put it over here. So from here magnification, which is basically d upon u को I can write df upon d plus f, and from here solve करना पड़ेगा थोड़ा सा. D and D will get cancelled out. This D plus F will go up, and from here one more formula will come, 1 plus D upon F. So this is one more formula for the magnification beta by alpha. M is equals to Hi by Ho, beta by alpha, D upon U, and in terms of focal length you can write 1 plus D upon F. Please, in these formulas, don't put sign. Okay? Or even if you put the signs, then can you see D and F will be, no, don't put sign, otherwise the formula will become different. So anyways, एक बार go through the whole thing and then we'll be moving on to the next one.
And sir, can you explain that line?
Which one?
I sent it on the chat.
एक
The meeting chat.
the maximum angle it can subtend, and guys एक बार ये भी देख लो. The maximum angle it can subtend and be clearly visible. तो मेरे को एक बात बताओ कि when the object is placed at the least distance of the distinct vision, when the object is placed. So basically, can you see over here, without a lens you are placing. So
Mm.
when the object distance is placed at the least distance of the distinct vision, or basically at the near point, this angle subtended by is basically what? Theta naught. Theta naught is basically the alpha which they have taken. Theta naught is the alpha. Okay.
Angle subtended by the object.
When placed at the near point.
Okay, and this is not with a lens.
No, with a lens, without a lens लिखा हुआ ना, तभी तो direct object को रखा है मैंने. I am not placing the image at that point. So is this clear, guys? थोड़ा बहुत
Yeah.
ये वाला clear हुआ? Because this beta and alpha will be very confusing and all. But is it clear? Any doubt in this?
Here, how have you taken alpha, sir?
हाँ बेटा.
यहाँ
Here
पर
alpha I have
हमने
taken
कैसे?
when the object is placed at the least distance of distinct vision. Without
So
a
the
lens.
same thing.
It's the same
Without a
thing. Theta
lens.
naught is basically the one which is given in your NCERT. Theta naught is basically the alpha, and this one is basically the beta. I think it will be taken as theta dash maybe. So anyways, this was your simple
So
microscope.
this is when you keep your eye like really close to the lens.
That's
why the
when
same,
you
like-
just use the lens and the image is formed at where? The least distance of distinct vision.
Okay.
When you subtend
Then
the
that is
angle
with
of
the
that
lens,
image,
right?
or you can say when the object is placed where the least distance of distinct
Least
vision is
distance
basically
of
alpha,
distinct vision.
and when the image is placed at least distance of distinct vision is basically the beta.
Okay.
It's rather simpler. तो एक बार फिर भी again go through it once, है ना? चलो question में दे रहा हूँ. Let me give you a question. If a focal length of a magnifying glass, basically simple microscope, है ना, is 5 centimeter, find the magnification of this simple microscope or lens for relaxed and strained eye. Now what do you mean by this? Sorry, can anyone tell me what do you mean by this? For relaxed eye. Tell me this particular thing, guys. For relaxed eye, where shall be the image? Image should be produced at, the final image should be produced at, for relaxed eye the image is produced at infinity, right? And if the image is produced at infinity, then magnifying, acha, by the way, this m which we have written, no, is basically called as magnifying power. Okay, so
Okay.
if I want to, this m is also called as magnifying power. Magnification, hai na? But the one you call as magnification is also called as magnifying power. So magnifying power is equal to d by f in the case of when the image is formed at infinity. So the least distance of distinction is nothing. If nothing is given, then you take it as 25 centimeter divided by the focal length, which is basically 5, and hence the answer will be 5. And if I have a strained eye, so from here just the straining will begin, right? With the image is formed at least distance of distinct vision. So just pay attention on the words. If it is relaxed eye, then what will happen? If it is, so magnification, magnifying power is basically 1 plus d upon f, which will be 1 plus 25 by 5. So can you see this is the minimum possible? Matlab, this is the minimum magnification without straining, and this is the maximum possible magnification which you can do. Anyways, can you see I have not used any signs and all. Directly I have used them. Is it clear, guys? You understood my point now?
Yeah.
Yes, sir.
Don't put sign in this. Direct answer आएगा. Sure. One more question. A man with a normal near point d equals to 25 centimeter reads a book with small printing using a magnifying glass. Please remember again, magnifying glass, simple microscope, है ना? Of focal length 5 centimeter. What is the closest and farthest distance at which he can read the book using a magnifying glass, using this magnifying glass? Okay, so initially the question looks unsolvable कि सर पता नहीं क्या पूछ रहे हैं, right? But understand the question very carefully. Initially, if I want the closest distance, है ना? For closest distance I want, u should be such that u is basically the object distance, है ना? Not u. U should be such that the image forms at least distance of distinct vision. So if I want the closest possible distance, then you should place the book at such a distance so that the image forms at the least distance of distinct vision.
Hmm.
So basically, you should be said that v is basically equals to minus 25 centimeter, right?
Yeah.
So using lens formula, if I say, so by lens formula, 1 by v equals to 1, sorry, 1 by f is equals to 1 by v minus 1 by u. From here, can I write 1 by u is basically 1 by v minus 1 by f, which is basically equals to 1 by v is how much? 1 by minus 25, and for it's a convex length, so plus 5, right? Yes or no? So from here, you आ जाएगा, calculate कर सकते हैं. We can calculate 1 by 5 minus 1 by 25. It is basically 25 by 4. 9. This will be minus minus, so plus यहाँ पर minus. है ना? हेलो पीपल, ये क्लियर है क्या? This will be minus 1 by 25 minus 1 by 5. So I have taken minus common and 1 by 5 plus 1 by 25. So this will be 6 minus 6 upon 25, and from here u is equals to minus 25 by 6 centimeter. So basically इतना समझ में आया. And
Hmm.
for the farthest distance, u should be such that image forms where? Image forms at. That implies object shall be kept at focus, which is u equals to, if you remember, it is negative, right? So minus 5 centimeter. 5 centimeter in front of. Is it clear? So basically,
Yeah.
these are some questions which are based on simple microscope. Now let's move on to compound microscope. Are you done writing, guys? See, simple microscope, it has its own limitations. It cannot enlarge beyond a further value, right? But what if we want to see more microscopic particles, right? If we want more higher magnification, then we need to use compound microscope for higher magnification. You might have seen this in your biology lab, right? Com- ये देखा सबने स्कूल में?
Yeah.
Guys, everyone, I think everyone might have seen this thing, right? So basically, this is a compound microscope, and we'll try to draw a simple diagram, schematic diagram, what is exactly happening in this case. So basically, it uses two different lenses. First lens is called as objective lens. It is called as objective lens because it is closer to the object. Whatever object which you want to watch, it will be closer to that object, right? It is closer to that object. Hello. Please remember, this lens has a short focal length and short aperture as well. It has short focal length and short aperture. Whereas there is another lens which is called as basically the eyepiece lens, or simply eyepiece, right? What is this eyepiece? Eyepiece is the lens which is closer to the observer's eye. So basically, in this diagram, the eyepiece is located somewhere over here, and this, can you see, guys? This is basically your objective lens, and this is basically a light source, है ना? यहाँ से light आएगी. This light source, illuminates the object which you placed on, this particular, what do we call it? Platform, and it illuminates it from the bottom, and then the light enters through the objective lens and goes through this thing to the eyepiece, right? Yes or no? ये सबने देखा है, I guess. You can
Hmm.
adjust the height of the platform. You can, rotate this thing for different magnification. 3 or 4 lenses are there, है ना? You can clear this thing by, you can adjust the intensity of the light using this. So I think everyone has used this in their school, right? So eyepiece is basically closer, it's closer to observer's eye. Also remember, this is also of short focal length, but it has a large aperture as compared to the objective. It has large aperture but short focal length only. ठीक है? Both the lenses are arranged. Both lenses are placed coaxially. What do you mean by coaxially? That implies their optical axis has to be same, and the distance of the object lens can be adjusted with something called as rack and pinion arrangement. Adjusted with rack and pinion arrangement. The one which I told you, you can move the rack up and down. You by that knob, by rotating that knob, you can adjust the position of the rack. Right? Hello. By rotating this thing, you can adjust the this rack up and down. Right? So you can basically do what? You can control the object distance. Yes or no? Hello. Is it clear?
Yeah.
So now see this, guys. Again, I'll have two cases. I think so. Case one, when image is formed at near point, और near point की जगह पे can I say at least distance of distinct vision, और near point ही बोल लो, क्या फर्क पड़ता है? Okay, at लिख लो near point for general, है ना? So anyways, let me just draw the diagram for you. Guys, can you see this particular thing? Diagram. Can you see
Yeah.
there is this, shall I make it much more bigger? It's fine.
It's fine.
Can you see this objective lens? Can you see it is having short focal length, and this has a large aperture, small aperture. Focal length is both short only. है ना? What is FE? FE is basically the focal length of eyepiece. And what is FO? It is the focal length of objective lens. Is it clear? Is it clear, guys? Hello. Please remember, both eyepiece and the objective lens are converging in nature. So both has to be converging. Now for the image to form at the near point, what exactly am I doing? Can you see the object is placed a little away from the focus? Can you see? For the image to form at the near point, the object distance is adjusted such that distance of object from objective lens is greater than greater than the focal length of the objective lens. Is it clear, guys? Basically, u naught should be greater than f naught. Is this clear, guys? Can you see over here? This is the focus. Everyone, are you drawing this diagram? Can you see over here the object I placed it at a distance u naught which is greater than f naught? That's why the object is a little bit away. So can you see when the object is in between the center of curvature, or basically twice of f naught, two times of f naught and f naught के बीच में होगा, तो where will the image form? The image will form somewhere over here beyond 2FO, right? Yes or no? The image of this object forms beyond 2F0 on other side of the lens. Guys, इतना clear है? Can you see just the
Yeah.
first diagram? Don't see anything regarding the eyepiece, just see where. Can you see the AB object was there? So one light ray is going like this, another light ray is going like this. So can you see the object is, the image forms over here, A dash B dash. So for the object AB, I can write object is basically AB and the image is basically formed at A dash B dash and the lens is basically what? Objective. Is it clear? इतना clear है क्या? Now we adjust the object distance in such a way that this image which is formed, guys, can you see this image A dash B dash? It forms between the focal length, between the principal focus of the eyepiece and the optical center of the eyepiece. Now the rack and pinion adjustment, you can ऐसे मत लिखो, you can just write this image A dash B dash from the objective lens shall form between the principal focus and optical center of eyepiece. Guys, is this clear? Can you see this image A dash B dash which is getting formed is in between the optical center and the focal, principal focus of the eyepiece. Is it clear? Guys, is it clear kya? Hello? Is it clear?
Yep.
If that
Yes.
gets clear, so can you see now for the eyepiece, the object, this image will act as an object for this eyepiece, right? So where will the image, final image be found? The final image be found at some, this distance, let's say. So can you see one light ray is going like this, one light ray is going like this, and when I can, produce these lines in the backward direction, can you see the image of A dash B dash formed at A dash, A double dash, B double dash, right? This is my final image. Can you see this object was below the principal axis? So image is also below the principal axis. Virtual erect and enlarged image. So just like a simple microscope, the remaining function. Is it clear? So can you see, guys?
Yeah.
From this small object, you achieved a little bit higher magnification, and from this higher magnification, you achieved a further more higher magnification. So with the compound microscope, can you see the magnification? You increase the magnification by some extent, right? That is what the function of compound microscope is. Is it clear? The image E dash B dash from the objective lens shall form between the principal focus and optical center of eyepiece, such that a further enlarged virtual and erect image with respect to A dash B dash is formed for eyepiece. And let's say that image is basically what? What is that image? It is A double dash B double dash. This is the image for eyepiece. Is it clear? Is it clear, guys? So what is acting as the object for objective AB? The image for objective is A dash B dash. What is acting as an object for eyepiece? It's basically this image A dash B dash. And the final image is formed at A double dash B double dash. Is it clear? इतना clear है guys? Guys, is this clear?
Yeah.
Now, can you see clearly over here? If you have this, then अभी I'll not solve the whole thing, but ये explain कर दिया मैंने पूरा. So there is something called as tubulent, है ना? तो केस वन समझ में आया कि सबको guys? Case one, did you understand? Guys, did you understand the case one? If I use the lens formula for objective lens, so the object distance will be minus of u naught, the image distance will be I don't know what, and although it has to be positive, right? So let's name it as VO. So plus VO, and the focal length of the object is plus FO. So I can put this in the formula: 1 by V minus 1 by U is equals to 1 by F. So that implies guys, 1 by V is equals to 1 by F plus 1 by U. So this will be equals to what? Is equals to plus FO plus minus U naught. So when I solve this, I get V naught is equals to U times of F naught upon U minus F naught. Yes or no? Yes or no? Guys, do I get this on solving? Guys, do I get this on solving? And what will be the
Mm.
magnification by objective lens? So M is equals to plus V by U, which will be equals to plus into plus of V naught by U is minus of U naught. Can I write V naught over here? So U so from here if I solve this, will the magnification be equal to क्या आप देख पा रहे हैं guys? I'm just solving normally, just like I solve every other problem. I'm trying to solve it normally, exactly like this. U naught say U naught कट जाएगा, this minus sign will go over here and it will become like this. So this is for objective lens, right? अब if someone says कि what is the magnification by eyepiece, magnification by eyepiece. Now, can you see over here? Hello, guys. Can you see over here? This magnification by eyepiece is basically the first case. Is the simple microscope. Can you see simple microscope case one? When the object is formed, the image is formed at the least distance of distinct vision. So basically I can use the same formula over here. The magnification by eyepiece will be equals to ME will be equals to 1 plus D upon the focal length. The focal length of eyepiece. I wrote it. So this is the magnification by eyepiece. Case 1, when image is near point and the final image by eyepiece is at least distance of distinct vision. So this is basically your formula. Is it clear? So this is the magnification by eyepiece. This is the magnification by this thing. And case 2 will be, acha, don't write case over here then, because only the case changes for eyepiece, not the whole thing. So for objective lens, this is going to be the same. But case 2 is when final image is at infinity. Then the magnification will be D by. So basically that is the magnification of the eyepiece, and that was the magnification of, guys, is this clear? Magnification दोनों केस में ME and MO. Is
Yeah.
ME and MO clear to you? So if I talk about the total magnifying power or total magnifying power of a compound microscope, that will be equals to what? That will be equals to what? The total magnifying power of the compound microscope, will it be equals to MO multiplied by ME? I told you, whenever there is a combination, you use what? Whenever there is a combination, you multiply them, right? Hi, Anna.
Yes, sir.
So basically, when you multiply them, you'll get this will be equals to what? Hmm? Okay. So either you can use this F naught upon F naught minus U naught, or you can use this minus of V naught upon U naught. It's up to you. Okay. So either you can use minus of V naught upon U naught into 1 plus D by Fe. This is when, for case 1, final image at least distance of distinct vision, LDDV है ना. अब मैं बार बार नहीं लिखेगा पूरा पूरा. Case 2, magnifying power of the microscope will be again M naught into ME, which will be minus of V naught by U naught into D by Fe. Is it clear? Please remember,
Yeah.
these signs are not to be put with. Don't put sign. Why shall I not put the sign? Because sign already I have put the signs, right? Can you see over here? Plus V naught minus U naught. I have already put the signs and so on. Is it clear?
Yeah.
This is the magnification by objective lens, and that is the magnification by eyepiece, which has two different cases. Please remember, the eyepiece behave exactly. Note करके आप लिख सकते हैं. Eyepiece behaves exactly like a simple microscope. Is it clear? But only we added one more thing. So that is your compound microscope. Any doubt?
No.
ठीक है. So let's do some numericals, and then we'll move to the refracting and reflecting telescopes. I think only these two derivations are there in your syllabus, right?
Yeah.
Hmm. So बाकी के फिर मैं ऐसे ही दे दूंगा. So a compound microscope question है guys. A compound microscope has magnifying power equal to 30. If it is producing, always remember, it is very important for you to find out where exactly is the final image is found. Is the final image found at infinity or is it found at near point, right? If it is a producing final image at near point of 25 centimeter, this is basically the least distance of distinctness, है ना? Question is, find the magnification of objective lens if eyepiece has a focal length of, sorry, please remember optical instruments are case specific. So generally we don't use sign conventions in the formula, any formula. How will we do it? Can you see, guys? They have given what is the focal length of the eyepiece. If they have given the focal length of the eyepiece, D is also given, and they have told the image is to be formed at near point. Then can I say the magnification of eyepiece is equal to 1 plus D upon Fe? Yes? Can I say this?
Hmm.
So will it be equals to 1 plus 25 by 5, which will be basically 6? And we know this particular thing, magnifying power of the whole microscope, compound microscope, is equals to MO into ME. So from here I can find out MO, which has been asked in the question. So MO will be basically the total power, or I can write this as 30 is equals to MO into 6. So from here MO will be equals to, MO will be equals to, hello, 30 divided by 6, which is basically 5. Okay, please remember this is only magnitude. Only magnitude has come, right? Because we know in the case of a compound microscope you will write it as minus 30, right? Because if it is producing a 30 times magnified image, that implies it is telling you if this object is having a size of 1 centimeter, then this image A double dash B double dash is 30 times bigger. Is it clear, guys? Magnification power 30 means what? If this is object AB having 1 centimeter size, then this A double dash B double dash will be 30 centimeter high. And that too, can you see virtual, इसके हिसाब से तो it is real and virtual and inverted, right? With respect to this object, is this image virtual and inverted, or will this image be real and inverted? बताओ जरा. Tell me, in the last case, does this image and this image, do they have the same nature? In the sixth case of convex lens, does the image and object are of same nature or opposite nature? Guys, can you tell me this answer? In the last case of convex lens, sixth case, where for a real object virtual image is found, no? So say, do they have same nature or do they have opposite nature? They have opposite nature, right? ये real image रहती है, real object के लिए virtual image is found. Can you see a real object, real image, and from this real image again a virtual image is found. So with respect to this object, this image is virtual, inverted, and enlarged. With respect to this object, A double dash B double dash is virtual, inverted, and enlarged. सारे cases possible थे. I already told you from the very beginning. Okay, is it clear, guys? So basically, this magnification is minus 30. So from here, this will become minus 5. If sign is included, then. If not, then no problem. Is it clear? Any doubt?
No, sir.
ठीक है. Next question. In a compound microscope, objective has a focal length of 0.6 centimeter and eyepiece has a focal length of 5 centimeter. separation between them. अच्छा हाँ, मैं आपको एक चीज बताना भूल गया. There is something called as tube length. What is tube length, guys? What is basically tube length? Tube length is basically the distance between the eyepiece and the objective. This is called as tube length. Is it clear?
Hmm.
So basically, if you can just measure this distance between eyepiece and objective, then your answer will come right directly. Or I think you can do it, using your little bit skills of maths. Can you see this? Basically, this distance is how much? यहाँ से यहाँ तक का distance is basically UE, right? Hello. And यहाँ से यहाँ तक का distance is basically VO. So what is the tube length in this case? Guys, what is the tube length in the first case? Case 1, tube length is VO plus UE. This is the tube length. You can just find it out. Na? A little bit of maths will be required and little bit of physics will be required. But you can easily find it. The separation between them is 12 centimeter. Find object distance and final image. Find object distance for final image to be formed at near point. Also find the magnifying power of the microscope. Find it out, guys, and give me 2 minutes. I'll be back. Hello, guys. Done. Dekho. For eyepiece, what has been given in the question? For eyepiece, what has been given in the question? The image has to be formed at what? 25 centimeter. So we know this particular thing. Where is the image formed? With respect to eyepiece, the image is formed towards left. Yes or no? Yes or no, guys? So can I say the image has to be formed at the near point? So for eyepiece, the image has to be formed at minus 25 centimeters. I'm taking this convention, positive on this side, negative on that side. Enough? Yes. What is the focal length of the eyepiece? Guys, what is the focal length of the eyepiece? Can you see it's a convex lens? So its focus will lie somewhere over here. So plus Fe. So hence plus 5 centimeter, because it's given in the question that the focal length of eyepiece is 5 centimeter, so plus 5. So from here, this U I can find it out, right? So from, can I say 1 by v is equals to 1 by u plus 1 by, can I say this? No, sorry, I want to find out u, no? So 1 by f is equals to 1 by v minus 1 by u. So from here 1 by u will be equals to 1 by v minus 1 by f, which is 1 by minus 25 minus 1 by plus f. So when I'll solve it, I'll get u as minus 25 by 6 centimeter. I'm not solving the whole thing. I think you people can solve it easily. So u image pata chal gayi. So object distance we got to know it is minus 25 by 6 centimeter. That implies what we found out. We found out what is this distance, a dash b dash, right? We found out a dash o dash. Guys, is it clear? Hello. Did we find out o dash and a dash? And now they have given the distance between the optical center of eyepiece and optical center of objective is basically 12 centimeter, right? This is basically distance between SN. This distance was 12 centimeter. This is your A dash B dash. This distance we got to know is 25 by 6 centimeter. The final image was forming where? The final image was forming at here. Can you see A double dash B double dash, which is basically at a distance of 25 centimeter. So for that object is 25 by 6. This distance is 12. So what will be this distance, guys? Can you see what will be this distance? This will be 12 minus 25 by 6, right? So what is 12 minus 25 by 6? Is equals to 6 12 से कितना होता है 72 है ना 72 minus 20 is 47 by 6 centimeter. So this distance is 47 by 6 centimeter. Now we get to know the image for the objective lens forms at a distance of 47 by 6 centimeter. So for objective lens, the image forms at plus 47 by 6 centimeters. What is the focal length of objective lens given? 0.6 centimeter, which is you need to find out the object distance from the system. So again, v is given, f is given, u is nikalna hai. So 1 by u will be equals to 1 by v minus 1 by f. And when you will apply this thing, from here you will calculate u and it will come to be minus of 0.65 centimeter approx. So can you see the object is placed very close to here, somewhere over here. The object will be placed somewhere over here. Any doubt, guys? So basically you need to remember the exact case, then only you will be able to solve it. This distance is 0.65 centimeter. This is where the object is placed, and that is how the whole image formation is there. Is it clear? And you can find out the magnifying power as well by using formula is equals to minus of v naught by u naught into 1 plus d by fe. So it will be minus of, am I not able to write, minus of v naught कितना है 47 by 6 I guess. So 47 by 6 u naught is basically 0.65 into 1 plus 25 by 5. That's the final answer with the sign will come. Anyways, is it clear, guys? Questions based on this is clear, guys? Is it clear?
Yes, sir.
Now you have a refracting telescope after this. Okay. Basically, this refracting telescope is used to see heavenly bodies, right? Yes or no? It is used to see heavenly bodies. It has two lenses. Again, two lenses. One will be closer to the object, and obviously you can't reach. ऐसा नहीं कि वो इतना बड़े planet के पास में पहुंच गए सर. No, it's not like that. Basically, comparatively, if I talk about, again there are two lenses. One is objective, one is eyepiece. Objective will be close to the object, whereas eyepiece will be close to the observer. Always remember, in this case, the objective is having large aperture and a large focal, whereas the eyepiece has small aperture and short focal length. Okay, so I'll
Yeah.
again give you the two cases. Let me just download the image. These are my notes. So ultimately, I couldn't, crop it or anything. I had to upload it in a very hurry. And one more. So guys, can you see both the cases? Shall I, do this? Enlarge it. It's fine. Can you see, guys? This is the objective lens of large aperture and large focal length. This is the eyepiece which is having less focal length and less aperture, right? In the same case, both the cases same, right? Yes or no? Hello.
Yeah.
See very carefully over here, guys. If the object is at infinity, then parallel rays would be coming from this particular thing. So can you see parallel rays coming in this case as well as this case, right? Where will the image form if the light rays are parallel? The image will form at the focus. So can you see the image is formed in the focal plane and a very small image is formed of that big object, right? So can you see the image is formed for, I'll write the whole thing again. If I talk about objective lens, where is the object? Object is at infinity. So parallel incident rays on objective. Yes. Where is the image formed? Image is formed the focal length, focal point of the objective fin. You know, a very real inverted and small image, point size image as compared to the object, right? As compared to the object, can you see there is a point sized image? This image will be very small, right? Is it clear? Now the eyepiece can be moved depending upon where we want with the final image. If we want the final image at infinity, case 1. If we want, like, sorry, final image at least distance of distinct vision, then can you see case 1, guys? Sorry, this one. This is case 1 and this is case 2. Okay, so case 1, see guys over here, if I want the final image to form at where the least distance of distinct vision, can you see from the eyepiece, then the distance of the eyepiece should be adjusted such that distance of eyepiece should be adjusted such that the image from objective lens lies between the focal principal focus of the eyepiece and the optical center of the eyepiece, right? So you adjust it in such a way that, can you see over here, the image is between the focal length of this and this. Can you see? Is it clear, guys? Are you getting my point? The image forms and is in between the two things. When this happens, then final image is at. So basically, you should adjust it in such a way. UE should be adjusted. Object distance from the eyepiece should be adjusted such that the final image is at least distance of distinct. Is it clear? Is it clear, guys?
Yes, sir.
So basically, the same thing goes again. You can do the whole thing, but I'll just directly give you the formulas. The magnifying power will be again equals to minus of V naught by U naught minus of V naught by U naught into 1 plus. Acha, by the way, this will come 1 plus Fe upon D, है ना? Shall I do the whole derivation? Okay, fine. Do you have this derivation in your school point? चलो कोई बात नहीं. We'll do the derivation in the next class. Let me just discuss the cases
Okay.
of this.
Mm.
Case 1 is basically this is the whole concept behind it, and case 2 is again, if you want the final image at infinity, then distance of the eyepiece should be adjusted such that control C, control V. The distance of the eyepiece should be adjusted such that the image from the objective lens forms on the focus of eyepiece. So basically, can you see in the second case, the image is formed at the focus of eyepiece. Can you see Fe is lying over here? FO and Fe is common. Please remember, in this case, the primary focus of objective should lie on secondary focus of eyepiece. So can you see both the focus, they are lying at the same point. FO is also lying at the same point and FE is also lying at the same point. Then the final image is formed at infinity. Any doubt in this? समझ में आ गया, guys? Case 1, case 2. In the next class,
Yeah.
we'll try to do the derivations for this. And although it's not there in your syllabus, I think the derivation part is there. In school syllabus, is the derivation there? then we'll see refracting telescope, reflecting telescope, and we'll do some questions. So only a small amount of it is left. Only half an hour portion is left for optical instrument. We'll be done with that in the next class, and we'll be starting with the wave optics in the next class. Okay? Is it
All
clear,
right,
guys?
sir.
Okay.
Yeah.
Chalo, okay. Uh, uh, we'll see you again then. Thank you very much.